Hey GAC, this is Coach Jay. I am right now in Starbucks with just getting ready to go on this Monday morning, and just wanted to give a quick podcast out to y'all on section 7.3 and 7.4. Again, if you have questions, please feel free to contact me. We know that we have a test coming up this week. Also, a room and study session coming up as well. I'm going to get right straight into it with section 7.3, and we'll mix in a little bit of section 7.4 as well. One of the first things that we need to kind of go through is just a couple of the details regarding 7.3. Now remember that there's a lot of little formulas with this. Some of them we'll be able to have on the test, some of them we won't. So it's important to kind of know which is which goes with which one. It kind of goes from there, okay? Now remember, with a vector, there's two different things that come with a vector. We have magnitude and direction. So that's really important to know. Now, remember the difference. Sometimes some people get confused with the difference between component form and then also something where we have 2 points. You know, think of it, if I have 2 points, right? That's not a vector. What makes it a vector is when I go from one to the other or make it from a head into a tail. And so because of this, we want to try to get 2 points into vector form. We know we can do that, put it in component form by doing x2 minus x1, comma, y2 minus y1. Now remember, the tail always represents the second, where the head is always the first. So if I was doing this, I would do -1 minus 3 and get -4. -4 minus -8 and get +4. So in my component form, -4, comma 4, exactly what my vector would be in terms of that. Also, if I was changing it from component form to what we call linear combination form, we can do that by doing setting the first one with I and the second one with J. Make this -4 I plus 4 J. And a lot of times you'll see me do a little hat like that on there, representing it's a vector, and also just have a line over top of it. So that's linear form, linear combination form. This is component form. It's important for, especially the test, just that you know that. Okay? Also make sure that you know this, that when we have something that's in component form, we can graph this by putting it left, in this case left 5, and then up to 12. Okay? So it goes up there, and starts at 0, 0, right? So we have a vector that goes in this direction. Now if I was to find the magnitude, I could do that by doing the Pythagorean theorem, find what C is. Remember, C is always positive. So we could say then 12 squared plus -5 squared equals C squared, and now we're rocking and rolling. So we have 12 squared, which is 144, -5 squared is 25, C squared, and when we add this, we get 169 equals C squared. C will be equal to 13. So if C is 13, we got that as our magnitude. We represent that as 2 lines over to the left and the right of our vector. So we say the magnitude is 13. Also, this is important. You have a radical, unless if it's a word problem. In that case, you don't have to worry about it. But if it's a just like a radical, like in this case, let's say if it was a square root of 60 or something, make sure you simplify that radical. If you have a question on the test, you can ask me which form you want to use. Also important, because we have 2 things, right? We have magnitude, or the distance I travel, as well as direction. If I was trying to find what theta is in this case, I could do that by saying tangent of theta equals opposite, which is 12, over adjacent, which is -5. So I can take the tan inverse to get that theta by itself. And when I put tan inverse 12 or -12 over 5, and I'll get what I'm looking for. Just remember a couple things when we find, just some little things we try to solve for that there. Another thing that we can do, let's say if we had 2u plus b, we can multiply and then add vectors together. So in this case, I can multiply 2 times u. When I do that, I get in component form, I get -6, 14 as my 2u, right? So I multiply 2 inside, and then I'm just going to add 8, -2, to each other as well. When I add, it's pretty simple. -6 plus 8 is 2, and 14 minus 2 is 12. So 2, 12 in component form is exactly what we're looking for. We can add, multiply, do whatever we need to do to simplify those vectors there. Okay. All right, we also sometimes want a vector to not be as long. We'd like it to be just 1 unit long. Sometimes it uses to simplify here. So in this case, let's say I have vector -3, 4. What I can do is I can put it over the magnitude. In this case, the magnitude would be 5. So what we could do is put the 5 underneath and then take the 5 to both of these on the left and to the right. This would be -3/5 and this. So it's the same vector as far as direction, except now it has a magnitude. We would put that to magnitude. The magnitude would be 1 because we call it a unit vector. All right, I know I'm hitting these fast. Hopefully this is making sense here. We already did the I and J, or the linear combination of unit vectors here. We've already done the angle. I'd like to do 2 more here. This one says find the component form of the vector. Represents velocity. It has a speed of 100 miles per hour and an angle of 30 degrees below horizontal. So it's kind of descending, right? It's descending as the plane is. So I start at 0, 0, and it says below the horizontal, so we know 30 degrees is going to be in that direction. I'm make this triangle here. Next thing I'm going to do is I know that my I and my J are going to be here and here. Again, I use that in physics over the component. So I've got to find what I and J are. I also know that 100 miles per hour is my hypotenuse. That's what my hypotenuse is. So I could say, in this case, sine of 30 equals opposite, which is J, over hypotenuse, which is 100. And to find the I, you guessed it, we're going to go right straight into the cosine of 30 equals over 100. Good. Okay. Multiply by 100 on both sides. I'm doing it for both equations so you can see, but 100 sine of 30, I'm going to put that in my calculator real quick. Make sure I got it. Sine of 30 and 100 cosine. So 100 sine of 30 is 50 and cosine is 86.680. So we'll say this, we'll say in our linear combination form, 86.60 I and 50 J. Now we've got to get the signs right. We know that this is going to be positive because it goes to the right. This one's negative because it drops down. So I'll just do this as one's positive and this one's negative. So that is our vector in terms of I and J. Now there's more difficult ones on our review coming up. Might want to just touch base with Coach on that as we progress forward. The last thing we want to think of on this is how to find an angle between 2 vectors. So to kind of give you a picture, 2 vectors that start at the same spot, where one goes up to 3, -6, right? There's our vector there. And this one, -3, -5, kind of goes down here. Okay? So what we want to do is we want to find what is the angle between the 2. That's between 0 and 180. So we can do that by saying, okay, cosine of theta equals u v, and I'll explain what that is. And then we know this is magnitude of u, magnitude of v. So to find the magnitude of u, I'll do 3 squared plus -6 squared equals c squared. So I'll have 9 plus 36, which is 45. So I'll keep it as the square root of 45. Now, on a previous problem, I would simplify that, right? We talked about that just a second ago. But on this, we're not have to worry about it really because we're not trying to find what magnitude is, we're trying to find what theta is. So no need to simplify. You can if you want to, but you might make it a little more tricky. Just add another step to it. And then I go to the other side. Over here, -3 squared is 9, plus 5, -5 squared is 25. So this would be the square root of 34. Okay. Now this top part up here, remember on this is called the dot product. It's where I take both of my vectors and I multiply the first two together to get -9. And I add the second two multiplied together to get 30. So really on the top I have 21 divided by the square root of 45 times 34. Now how do I get that cosine out of there? Well, we did it kind of earlier. Do the cosine inverse of both sides, right? So when I do the cosine inverse of both sides, I get theta by itself, which is my goal. I want to find that angle, right? Find the angle between the two vectors, and I can do that by doing the cosine inverse. So we're going to do that. We're going to say the cosine inverse of 21 divided by square root of 45 times 30. I got 57.53. So what we're going to do is just put theta equals 57.53 degrees. And that'll be my answer. So again, just kind of an update. It's kind of good for us to go through here. When we do any of these problems, the big thing is to know, hey, what formula are we using? A lot of times it's pretty simple as far as once I get the formula, how do I go about doing it? And that's really the big key. Again, if you have more questions, we are going to have a study session where we go into depth a little bit more on questions you may have. Other than that, hope you have a fantastic day, and we'll talk to you all later. Bye.